Mm. Okay, before we start, I have some information to share regarding the lab. Okay, so update for the lab. Instead of doing it online, we'll do it mix, combine between the online and the offline. Okay, so lab 1 you have done the online, so my plan is to do lab 2, 3, 4 offline, meaning you have to come to the lab physically. Start next week. Okay, yes.
How about for those who still take the...
Okay, don't worry. We'll discuss this later. Okay, let me finish first. Okay. I know some of you are still in your hometown, maybe even outside Malaysia, Indonesia, one of you in Indonesia, one of you in Nigeria. Okay, but most of you, I think, already in here, in Melaka. So don't worry. For those of you who are outside of Melaka, you can join another group. Of course, you have to do your part. I will discuss this in detail with the head of the class, with Huang, so you can ask her later on. But the point is, for lab 2, 3, 4, it will be offline. Okay? So because I want you to feel the physical device equipment. You have done the lab 1, which is simulation, 3-phase, a simple series in parallel of resistor. So for the next lab, 2, 3, 4, I want you to feel the physical component devices, and you can play around with the equipment. Okay, don't worry about the one that cannot come physically. I will try to arrange that so that you can join and do it. Okay. I will discuss in detail about who will come for example, group 1-1. I think group 1-1 have 25 students, group 1-2, 15, group 2-1 maybe 21. So unfortunately, some of you, because we are still on a pandemic now, so we have to follow the SOP. So I have to limit the students that come in the lab for one session. So one session can be maximum 16 students. So maybe some of you will go for the first batch, and then some of you will join the second batch. Okay. So I'll try to make it not too long, the lab. So will be enough for 2 batch then. Okay. Any question for the lab? So lab 1 online, lab 2, 3, 4 offline, lab 5 will be also online. I have uploaded the lab sheet for lab 2. So make sure you bring the lab sheet with you during the lab session next week, because you have to follow the instruction. You can print, you can put it in your phone or maybe in your tablet. Okay. I don't think there's a PC there. I have visited the lab. There is no PC, so you cannot access from PC, and even the signal is not good there. It's not sufficient, so I don't think you can access the internet from the lab. So make sure you bring the lab sheet with you during the lab session. You can either print or save it in your phone, save it in your tablet, or even save it in your laptop, maybe. Okay.
So,
Okay. Yes.
how about the grouping? Because the first step, 4 of us in one group. Because last time you said you wanted to separate, one group, 2%.
Yeah. I will discuss with Huang later on about the detail, but in one group they can only 2 students in one group. But unless for the one that cannot join, because you're still outside Malacca, Malaysia, so you can add in another group. So that one will be okay. But for the one that do the lab, that come to the lab, only 2 students in one group. Okay. Because one equipment will handle by 2 students. Yeah. So I don't know. Maybe you can. I think we better discuss this during in the between yourself, because I don't want to. I want you to give. I want you to form your own group. Okay. In one session, in one kumpulan. Make sure it's not from different kumpulan then. Okay. Another questions? Before we start. So I hope this physical lab will give some benefit for you instead of doing it all by simulation. Okay, yeah. If no question, we'll proceed. I think last time this one is done. I think this one. Okay. Induced EMF, electromotive force. Okay. Small e is EMF, electromotive force. I think we also discussed this one. Okay. 2 pi b n a and sine theta, and EP means peak or maximum. Okay, now right. Okay, this one. EP or EM, maximum. P means peak. Okay, maximum. 2 pi b n a n. Capital N, small n. Why is it? The difference is only in sign. There is no sign here, like this one. Why? because maximum value for sine, maximum is 1, right? The value of sine is always between -1 and 1, correct? So if you draw the sine wave, right, this is 1, this is -1. Sorry. This is -1. Okay. So maximum means sine theta equal to 1. So this is the EP, or maximum. You delete the sign. Okay. So induce M equal to EP sine theta. And then this one is angular velocity. No, angular velocity. Yeah? The velocity usually take a part of a circle shape. That will be angular velocity. And this one, I think you are familiar. Omega equal to 2 pi f, or 2 pi over t, right? Because f equal to 1 over t. Okay. So at the end, alternating voltage and current can be formed as a function of time as E equal to EP sine omega t, or IT equal to IP sine omega t. Okay. Let me see another one. Okay, example. EM, if EM or EP is the same, huh? Equal to 100 volt, determine the coil voltage at 30 degree and 330 degree. If the coil rotates at omega 300 degree per second, how long does it take to complete one revolution? Okay. So first questions, determine the coil voltage. So simply just by using this one, right? So E equal to EP sine, this one is 100, sine 30. Sine 30 is 0.5, right? How? So this one is 50 then, 54, this one. Okay. What about the 330? Same formula. So this one you replace with 330. Sine 330 is minus 0.5. Minus 0.5. So this one will be minus 54. Right. Okay. So next, if the coil rotates at omega 300 degree per second, how long does it take to complete one revolution? Remember, omega is 3 degree per second. As for this one, look here. The unit is radian per second. Okay. Omega where 2 pi f or 2 pi over t, big T, the unit is radian per second. Okay. The given parameter is 300 degree per second. So you have to convert from degree to radian. Convert from degree to radian. How to convert from degree to radian? Degree. Convert to radian. To, let me, convert to radian per second. And then you can use this formula. Because this question asking for time, t, right? So how? Basically, you multiply with pi over 180, right? Convert from degree to radian. If you want to convert from radian to degree, you can just do it the inverse, multiply 180 over pi, okay? So this one 0, this one 30, by 6 is 5, by 6 is 3. So pi radian per second, right? Is it 5 over 3 pi? Okay. So then use this one, this formula then. Delete this. So 2 pi over t equal to 5 t pi. Delete the, so 3 equal to 3 over 5 times 2. 6. 6 over 5. 6 over 5. 1.2, right? 1.2 seconds. Any question? Just your question, or maybe okay, now check. Maybe just ask directly. You can type question here. Oh, okay, here. Okay. Okay, yeah. Okay, if no question, let's proceed with the, okay, this one. Phase shift or phase different. Phase shift or phase different. Okay. Example, this one is a graph of V over WT. And this one, this is the normal one. If you see the sine wave, this is a normal one. Right? So if you look at this one, right? The graph, it goes to the left, right? Or in it goes to left, or in textbooks they use the terms lead. V is lead over W omega, so it's in here lead by theta here, this one. Right, so this is how you write the formula. In normal one, this one is V equal to Vm sine theta, right? Sine omega t, sorry, sine omega t. So if it's lead, V lead against omega t, so this is the formula, lead by theta, for example. But if V is lag over omega t by theta, so just use this one, minus theta. If it's lead, so plus theta then. Okay. So phase shift occur when they are L. L is inductor, or and C is capacitor, exists in the circuit. Three important situations. Okay. So if you have inductor or capacitor in your circuit, I believe in lab 1 you have no L and C, right? So it's just a resistor. So, but if you have L and C, so for sure you will have a situation where there are phase shift of the signal. Okay. So this is the three situation. Okay, in phase. In phase means there is no phase shift. There is no phase shift. If you see the red one, what's the red one? The red one is V. The blue one is I wave. The red one is voltage wave. The blue one is current wave. If you see, they start from the same point, right? They start from the same point here. Even the cross section is the same dot, and in the end, they'll finish also in the same point here. That means they are in phase. There is no phase difference, or the phase difference is zero. The words here, V and I, voltage and R are in phase since the angular displacement, displacement is a shift, is zero. Okay? Zero. Okay, second one is lead. Lead. The red one is voltage, the blue one is still current, but if you see here, they start from different point. This is V, this is I. They start from different point, even they cross the cross section, it also in different point. I mean, not compared to the first one, and they finish at different point. The difference, if you look at the difference, where the horizontal axis compared to the horizontal axis, this is the way they start. The red one and the blue one is this one, the starting point. The difference is, for example, this one, theta here. Okay, so we can say that V, voltage is leading I for certain amount of angular displacement or theta. Or instead of saying lag, I is lagging V for certain amount of angular displacement theta. Okay. The third one is the opposite situation. Okay, where I is leading because they start first I and then goes voltage here. Okay, This is the situation where I is leading V for a certain amount of angular displacement, or if we want to make it lag, that means V is lagging I for a certain amount of angular phase shift. Okay, yeah? That will be for the phase shift phase difference, where you have either inductor L or capacitor C in your circuit. If you have no inductor, capacitor, then there will be no phase shift. There will be no angular displacement. Okay. So, okay, this one. This one is your lab one. Your lab one. V and I in phase. That means no phase shift. No phase shift. Or zero phase shift. Okay. Capacitor. Capacitor reactance. You should remember this formula of impedance of the capacitor, right? So 1 omega C, that means V lags I by pi over 2. Or inductive, this is formula for inductive reactance, XL, where V leads I by pi over 2. Okay? Okay, I will not go too much on this one. You can read this one later on, but I want just to emphasize on the RMS value or average value. So RMS is abbreviation for root mean square, right? Root mean square. So basically, I'll go directly to this one. Where is it? Okay, this is the one that I think some of you may be familiar with this one. So I RMS equal to even V, you can say V RMS equal to V max equal to V max over square 2. You know, in daily life, RMS, if you measure, lab one, in multi-sims, you have to measure current or even voltage by using ammeter and voltage meter, right? Multimeter. Okay, you have to measure that one. So the one that's shown in the multimeter, the numbers, is basically the RMS value. RMS value. Okay. The one that show in any measurement of multimeter in the LCD, that one is the RMS value. Root means square value. Okay. In our home, in Malaysia, for example, the voltage from TNB is around 220 voltage AC, right? So that one, that numbers is RMS value. Okay, root means square. It's not maximum value. It's not average value. It's the RMS value. Okay. Yeah. Is there any? If you are wonder how they got this number, this one here. Okay, you can look at the textbooks. They will show you the detail how you get to the square 2 here. Because we're not going to discuss on how do you get the formula from, right, in here. We're just going to apply the formula, that's all. This is what I have written before, same. Okay. This is the called form factor or peak factor. Form factor basically value or RMS divided by average. Or peak or crest factor is value or maximum divided by RMS. I want to go to, okay, this one, phases. Phaser. I'll go to, okay, this one. Phaser where they are represent the magnitude and angle. Okay, magnitude and angle. If you still remember, last semester we discussed on terms that have magnitude only and terms that have magnitude and direction. Factor, right? Factor. This one, the terms is phasor, where they have magnitude and angle. Okay, magnitude and angle. So this is example of phasor. This one. This is how you write. Where this one equal to this one. Okay. So this is the diagram. Okay. So for example, I write Industry equal to EPA. Wait. Equal to EP with the degree of 45 degree. So how you draw the diagram is, if this is a horizontal line, if this is the EP, so this one will be 45 degree. Okay. That's how you draw the first diagram. Yeah. So in terms of writing in a complex form, for example, this one, this is how you write in a complex forms, where they have a real number and imaginary number. I, EP with theta degree, that means EP cos theta plus I, EP sin theta. Where EP cos theta is the real number and EP sin theta is an imaginary number. Okay. This one, okay, this is not example of phasor diagram. Sine, because this is sine. So you draw phasor diagram, sine. Remember, normal sine is this one. But because there is plus, yeah, so it will be leading, shift to the left, this one, leading by theta, right? Don't forget the maximum is Im, this one, okay? So this is the phasor diagram, this one, phasor diagram, where the maximum value is Im, and the degree is theta, for example, here, and you project it into wave, is this one, right? Into wave. So this one is 2 pi minus theta. This one is pi minus theta, right? Because in normal sine wave, yeah, this is pi, this is 2 pi. So if you shift to the left by theta, so all of the wave will also be shifted to the left by theta. Okay. The second one, okay, look here, minus theta. That means it's lagging. Shift it to the right. Okay. The wave will shift it to the right, but the phasor diagram will go inverse because it's minus. Okay, just now, this one is plus theta. So plus means this one, plus theta. Right? If minus, that means it goes down then in here. Minus theta. This one. Okay. So you start, if you project it to the wave, you start from minus, the maximum is okay, from minus Im then. Maximum still Im, minimum is minus Im. Okay. What about this one? Why am I? The value here. What is the value in here? Anyone answer? No. Huh? So this one will be pi plus theta. This one will be 2 pi plus theta. Because it's shifted to the right. Okay, example. Phase difference between voltage and current waveform are 40 degree and voltage lags. That means the current lead. Okay. Use current as the reference. Sketch the phasor diagram and the corresponding waveform. Okay. So the voltage is lagging. The voltage is lagging. So for example, if we draw the current, the blue one here is the current. So since the voltage is lagging, that means the voltage will be in here by 40 degree. Minus 40 degree, right? Because it goes down here. Okay. From here, you can project it the corresponding waveform. Look here. Okay. So since the current is a normal one, right? So it's a normal sine wave then. But the one that lagging is the voltage. The one that lagging is the voltage. So you start from here, lagging. Voltage. How do you find the 40 degree? Is from this one, where the current start, right? And where's the intersection, where the voltage hit cross the horizontal axis. Cross the horizontal axis. This one. So this is 40 degree. Or if you want to find out another 40 degree, it will be in well, in here, also 40 degree. This one, 40 degree. Okay, another example here. Okay, this one. Given V 20 sine omega t plus 30 degree and I 18 sine omega t minus 40 degree, draw the phasor diagram, determine phase relationship and sketch the waveform. So it's just by looking at this one, plus degree. So that means the V is leading. The V is leading. But then looking at the I is minus 40. I is lagging. Okay. But then look at the number. Is 30 degree plus is minus 40 degree. The difference is 70, right? The difference between plus 30 and minus 40 is 70. So it will lead by 70 degree or I lags V by 70 degree. So just draw here. The base, the reference will be the horizontal axis. Horizontal axis. So for example, V 20 sine omega t plus 30 degree. So VM is 20. So the 30 degrees start from here to here. 30 degree plus. For minus 40, it goes down in here. Minus 40. So the difference between this one is 70 degree. Okay. Now, how you sketch the waveform? Okay, remember the V is leading. The V is leading. The V is leading by 30. So it goes first. That means the V goes first. Yeah. 30 degree. So this is 0 degree. This is 0. The y-axis is 0. So you move by 30 degree in here. Then you start. Okay. How do you point out where the 30 degree? Okay, look here. If this is pi, this is 2 pi, right? 2 pi. So this one is pi over 2, right? This one is 3 pi over 2, correct? So half here is pi over 4, right? Pi over 4, if you convert to degree, is 45 degree. Because pi is 180, so 180 by 4 divided by 4 is 45. So 30 degree will be in here most probably, 30 degree. Right? So if you 30 degree this one, so if you are leading, the V is leading, so that means the same distance here. So most probably in this one, 30 degree leading. So they start from here. The V will start from here, and so on. What about I? I is lagging. So I is lagging by 40 degree. I is lagging by 40 degree. Wait, huh? Okay. So how do you find the 40 degree? Just now, this is pi over 4 is 45. So you shift it a little bit. So you get the 40 degree. So for example, this is pi. This is pi over 2. This is pi over 4. Wait, let me redraw it again. Make it bigger. This is pi. This is pi over 2. This is pi over 4. So pi over 4 is 45. So for 40 degree, it will be around here. For example. Okay. So basically, you just have to draw from this one. Okay, this one. That will be for I. This one. This one is I. This one is I. This one is V. Okay. If there is any question, just interrupt or you can just type in the chat room. Okay, let's proceed. I think this is the last one. Will be the last, yeah, will be the last topic here. Addition on subtraction of phasors. Addition or subtraction. Okay, I believe some of you may be familiar with this one. So you have A, you have B. So the addition between A and B is this one. C, right? So for example, this is B. If we proceed B with A, get this one. So the addition will be this one. C, B, A. Okay. Or resultant. What about subtraction? Subtraction. This is A. This is B. Here. Okay. The subtraction. If you want to add this one, if A plus B will be in here. Just like C. But if you subtract A and B, if you subtract A and B, is this one, the D. How? How is it possible? So this one is equal to A plus minus B, right? Correct? If this one is B, so minus B is this one. Minus B. Minus B. So if you add A and minus B here, if you add, you will have D. Right? You will have D. Just like if you remember, you still remember your Pythagoras formula. If you remember your Pythagoras formula, you project it, for example, this is A. Is A, right? You project it in here. Correct? So you have D here using Pythagoras law. Or you can also project it the B minus B, you project it in here. Right? You have the A here. Let me make it simple. Huh? Just now, okay, let me. Just now you have A. You have A here. A. But you have B here. This is B. B here. You want to subtract A and B. Subtract A and B, which is equal to this one. Because in here, if we subtract this one, if we project it, this is minus B, this will be minus B, right? Project it minus B. Okay. If we projected A into here, you will get this one. This one. This is A. So according to Pythagoras law, D here according to Pythagoras law equal to, or you can just, okay, let me make it simple. According to Pythagoras law, A equal to B plus D. Right. So D will be A minus B, correct? They want to understand the subtraction factor. Okay, let's see the example before we stop. Okay, this one. Instantaneous values of two alternating voltage are represented respectively by V1, 60 sine theta. Remember? V1 60 sine theta. Okay. And V2 sine theta minus pi over 3. 40 sine minus pi over 3. So this one basically sine theta plus 0 degree, right? 0. So this is how you draw. Because no degree here, 0. For V1, as for V2, you have this one, minus pi over 3. Or minus 60 degree. Right? This one. This one is minus 60 degree. Pi over 3. Goes down because it's minus. It's below the V1. It's minus. So you have to find the addition of both factor and the subtraction. Both factor. So first assume up positive, down negative, right positive, left negative. Okay, let's see this one. Okay, let's see. Okay, this one. Okay, horizontal component. the horizontal component, we have to project V1 into horizontal component. Remember this one? Projected to X. For V1 is 60 because no degree 0. For V2, cos 60 multiply with 40, right? If this is, okay, let me, this is 60, this is 40, this is X. So X is 40 times 60, times cos 60, right? Cos 60 is 0.5, so X is 20. So 20 plus 60, so total horizontal components is 80 volt. Okay, 80 volt. That one horizontal. Now project it to vertical, y-axis. Y-axis. You project to this one. Just now is y-axis. Now you project it to y-axis. So this is 30 then. 30 degree, yeah. Okay, for V1 is 0. Why is it 0? Because V1, if you project V1 into y-axis here, into y-axis, the degree is 90. The degree is 90. So sine 90 is 0. Cos sine, yes, sine 90. Cos 90, sorry, cos 90. Cos 90 is 0, right? Yeah, let me show you. Okay, this one. Yeah. What about V2? Okay, V2. Let me draw again. This one, V2. This is y-axis. Just now. Okay. This is 60. Okay. This is 60. So you have to project to this one, to y-axis. This is 40. That means this is 30, yeah? If you draw again, this is 30, this is 40, right? So you have to find y here. Y equal to 40 sine, cos 30. Cos 30. Why is it in here sine 60? Because cos 30 equal to sine 60, right? Which is 2. Okay. So minus 40 sine 60 or minus 40 cos 30, which is this one for V2. So total is the same because this one is 0. So down means this one, the y-axis, the x-axis is 80. So by using Pythagoras here, Pythagoras law, we'll find the total addition of the two faces. Okay. What about the degree? Degree here? Just by look at this one. The degree, you can tell degree. Yeah. Using this one. So tangent. Is it tangent or yes, tangent. Tangent theta equal to y. Y is 34.64 over 80, right? So by using inverse, you can find the angle theta. Okay, that one is for addition. What about? Okay, this one just now find the angle. Okay, so the addition is this one. Right, this is from Pythagoras. This one is number come from here. This one. Okay. Don't forget the angle. Minus. That means still goes down. What about the subtraction? Okay. This one is subtraction. So basically, V1 minus V2 equal to V1 plus minus V2. So remember here, this is V2. So if you minus, that means the direction will be the opposite, which is this one. This is V1. This is V1, right? So, sorry, not this is V1. This is V1. Sorry. This is V1. So the V1 minus V2 is this one. Yeah. Using simple Pythagoras, right? Okay. But then you have to project it just like previously. You have to project, divide into x-axis and y-axis for both V1 and V2. And do exactly the same like this one. Like this one. So let's see. Okay. So I will put this one as your first quiz. This one only. Don't need this one. This one. B. Question B. Try to solve this for your first quiz. Remember, your quiz has 5% weightage. So it's can help you increasing your mark then. So try to solve this one. V1 minus V2. Okay. You can discuss if you don't understand later during solving the problem. Okay. Is there any question before we stop? I'm not sure if in your, let me see your textbooks. Do you have, let me check. Yes, yes.
Sorry to interrupt, but just now I couldn't hear your voice. You were just mentioning about the lab 1, lab 2, about the online offline, is it? As long as what I heard is lab 1 is online and lab 2 is offline, but others I couldn't hear.
No, you mean even if during I explain the content, yeah?
Yeah, the content time I could hear, but just now the Wi-Fi was I don't know what happened.
Okay.
Sorry, sir.
What about the lab? Are you clear with the lab?
Yeah, clear with the lab, but only thing is just now you were mentioning about the lab 1, lab 2, is it online, offline? I couldn't hear.
Okay. Let me repeat then.
Okay.
So now we can do the lab. We can mix the lab, all 5 lab. So my plan is do the lab 1. You have done the lab 1, which is online, and do the lab 2, 3, 4 offline. That means it's physical. You have to come to the lab. Start next week for lab 2. Okay, and lab 5 will be online again. Simulation, multi-sims. The technical, the procedure, I will discuss with your head of class, the rep of the class, Wang, because we have to separate you even from the same session, same kumpulan. Due to the pandemic, so we have to limit numbers of students entering the lab. Okay. But you have to come according to schedule. Huh? So I'm not sure. I think it's on Tuesday morning, Tuesday afternoon, and Thursday. So Thursday. Let me see. Tuesday morning, group 1, 2. Tuesday afternoon, group 2, 1. Thursday afternoon, group 1, 1. Okay. But then even in one group, we have to separate batch by the batch because we have to limit the numbers of students. So I will discuss the detail with Huang. So you just refer to her later. But we will start by next week then. Okay. Who was just asking now?
Yeah, I'm clear of you.
Okay. Any other questions? Nothing footage, nothing can. Dua. Let me see. Mm, mm, mm. Okay, I see from the textbooks here are very clear, even how to derive the formula here is very clear. You can just read the books there, even the faces. Yes. Let me see. Yeah. Okay, so if you have no questions, we'll stop here. Don't forget your first quiz answering the V1 minus V2. So I'll give you 1 week to solve this. Submit the answer you learn. I will create the folder then for you to submit the answers. Okay, yeah? If you have no question, I'll see you next week during the lab session. Don't forget lab session. Okay, guys, see you next week then.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.